The 6050 from Baseline Technologies offers solutions for condition monitoring based on frequency analysis, in position dynamic balancing of rotors and vibration measurement, in a single, portable, and rechargeable battery-operated unit which fits into a briefcase. The unit can be switched on by pressing the on button. A battery bar is presented at this time. The user can press the glow button to enable the backlight of the display. The instrument starts up at the main menu with the following options: measurement, analysis, balancing, setup, clear memory, display RPM. Accept measurement and you get the following options. Overall, measures the vibration of all frequencies together. Press next for min/max, which indicates the minimum, maximum and mean of 20 successive readings. Press next for rotational, indicates the rotational elements of vibration. Next is vector, useful for assessment of relative phase. Inside analysis, you get the option to scan the spectra and view the major peaks of the saved spectra. Inside balancing, you get the option of single plane balancing and two plane balancing. You also have the option of single and double plane rebalancing. Inside setup, you can configure the 6050 for measurement, analysis, and balancing. Inside measurement setup, you can firstly select the vibration units, then toggle between channel 1 and channel 2 of the instrument. The cursor then moves to the sensitivity. This cycles between high, low, mid, and auto. Next, the frequency range may be selected from the options. Inside analysis setup, there is only one choice available: standard scanning range or extended scanning range. Standard range is 10 Hz to 1 kHz, and extended range is 1 Hz to 10 kHz. Inside balancing setup, there are two options available: correction method and vector indication. Correction method, addition or removal, can be selected for each plane, and vector indication can either be polar or Cartesian. Here is a demo of the 6050 used for vibration measurement. Acceleration, velocity, displacement or bearing spike can all be measured with the unit. The readings can also be downloaded to a PC for monitoring/printing, and thus a very simple yet effective predictive maintenance program can be established. The user can select the units of measurement, the measurement channel, sensitivity and the desired frequency range from measurement setup. Mount the accelerometer on the rotor properly and then monitor the readings by simply pressing the accept key on measurement mode. The 6050 features automated full frequency analysis. Frequency analysis can be done over the frequency range 1 Hz to 10 kHz, 60 CPM to 600,000 CPM. Its microcontroller scans the entire frequency range looking for spectral peaks. Each peak contains valuable information. Range magnitude of the peak is the severity of the vibration, and the frequency is related to the nature of the defect. If imbalance is the dominant cause of vibration, a peak will be found at the rotational frequency with a magnitude comparable to the overall vibration. With the PC software we scan, developed by Baseline Technologies and supplied with the 6050, the spectra can be quickly transferred to the PC over a serial port, where the spectra can not only be saved and printed on the PC, but also post-processed for further analysis. Enveloping is one such powerful tool, where limits are placed on a good spectrum, and if any portion of the spectral region grows beyond the envelope over time, an alarm is reported, pinpointing the defect developing in the machine. One can also view the history of the spectra, and thus, find out how a spectral peak has grown over time. At the end of the scanning process, the unit would ask that the scanned data be stored under some free memory. There are 24 memories, and you may store data in any memory of your choice. The memory number under which a spectrum is stored will be used to relate it to the actual location while analyzing the data. Here is a demo of single plane balancing using the 6050. Set up the unit for balancing as per requirement from the balancing setup. Set up the sensor and connect to channel 1 and suitably mount it on the rotor. Connect the RPM sensor for phase reference. Go to balancing, then one plane balancing. Then follow the instructions on the screen. Two-plane and single-plane dynamic balancing can be performed in situ with the 6050. It has all the required vector calculation algorithms built into its program. Thus the operator is freed from the task of determining the weights by calculations or hit and try methods, resulting in vastly improved, quick and accurate results. A sharp auto-tracking filter synchronizes automatically to the rotational speed and filters out all extraneous vibrations. It is also possible to compare the overall and synchronous vibration readings to confirm unbalance as being the dominant cause of vibration. Once the result comes, stop the rotor for the correction. The instrument is indicating that you need to add a weight that is 102% of the trial mass, and it is to be added at a position in the increasing direction, 270 degrees from the trial mass. After performing the correction, the unit will give you the option to save the constants, and then you can take a verification run to see the final vector. Here is a demo of two-plane balancing using the 6050. Connect one sensor to input 1, left plane, and the other to input 2, right plane. Make appropriate instrument settings in balancing setup. Connect the reference sensor, then go to balancing and select two-plane balancing. After setting up the rotor, follow the instructions on the screen, which will lead you to take the initial vector readings in plane 1, and then in plane 2. After that, stop the rotor, and add the trial weight in plane 1. After adding the trial weight in plane 1, run the rotor. The unit will then calculate vectors with the effect of the added trial weight in plane 1 and then in plane 2. After that, the unit will prompt you to stop the rotor. Remove the same trial weight from plane 1 and add it to plane 2. The unit will then calculate vectors for both the planes with the effect of the added trial weight in plane 2. Once the result comes, stop the rotor for the correction. In this case, for plane 1, the instrument is indicating that you need to add a weight that is 104% of the trial mass, and it is to be added at a position in the increasing direction, 67 degrees from the trial mass. Press next to view the result for plane 2. In this case, for plane 2, the instrument is indicating that you need to add a weight that is 110% of the trial mass, and it is to be added at a position in the increasing direction, 49 degrees from the trial mass. VS22 is a PC-based software developed by Baseline Technologies for transfer and management of spectrum files from the 6050 to the PC. In addition to file storage, it also enables spectral enveloping and spectral trending, adding immensely to the power of frequency analysis of the unit. The simplest way to view a spectrum on the PC is to transfer via memory number. This option will not save the file on the PC and should be used only for quick viewing of the spectrum. The user can also save the files under the group, machine, location system. First, a group name is to be created. Under the group, various machines can be created. Under each machine, various locations can be created. Each location will have a specified memory number under which the spectrum was saved during the route. The user must know which location has to be stored under which memory number. A brief demo of the software is given here. After transferring the spectrum files, the user can analyze the data. The files can be trended using the features such as the waterfall and other statistical plots available. The instrument has a detailed manual in the help section of the software in addition to the copy provided. Enveloping is a powerful tool, where limits are placed on a good spectrum, and if any portion of the spectral region grows beyond the envelope over time, then an alarm is reported, pinpointing the defect developing in the machine. Trending is the storage of vibration signatures recorded at specific time intervals and plotting the changes in vibration levels at the forcing frequencies versus time. An upward trend in level indicates a developing problem. The simplest way to utilize the concept of vibration trending is to establish a representative vibration spectrum of a normally operating machine as a reference, and compare this reference to spectra measured at later times on the same machine problem. At any time, the user can contact Baseline Technologies should there be any need for further clarifications.